I've been doing power-based bring-up of systems for a long time. My history in this goes back to when we still had PowerPC in like Apple systems, for example. So I know how much we've evolved from that world. Back in that day, we would use a bootloader called OpenFirmware, which is kind of arcane. I mean, it's probably before a lot of you folks' time. But getting involved with OpenPOWER, one of the things I've learned about is the opportunity you have, because the bootloader is open sourced, you have this opportunity to create a little suite of tools in that bootloader that can facilitate a lot of common bring-up challenges that in the past with our open firmware bootloader, you might facilitate with various kinds of I2C or FSI dongles or stuff. A lot of that stuff you can now do right from the OpenPOWER Petitboot environment. And I've gotten a lot of experience with that in the last year or two working with different OpenPOWER clients. The Petitboot console has of course, it's built on the BusyBox embedded standard for Linux. And this gives you a very rich set of tools inside this little embedded Linux system to facilitate bring-up. You've got this devmem tool that lets you do reads and writes to memory. You can grab a PCI config space, and a lot of times in your bootloader, you're trying to correct some little issue with an adapter, make it possible for it to boot. And so you have this capability to do that right in the Petitboot environment. There are some I2C tools. In a lot of the OpenPOWER systems, I2C is not that connected from the P8. That's usually a BMC task. I was in a presentation this morning on OpenBMC. That is going to be a huge way to extend this even farther, so you'll have even more ways to manipulate the system from an I2C world. And of course, the Petitboot BusyBox environments also includes a bunch of flash tools so that you can look at your device tree and look at the XML that makes up the system machine-readable workbook. It also has the LSPCI and set PCI standard Linux commands, so you can interrogate different things about the PCI endpoints. And because it's a Linux system, you can get in there and do like shell script type stuff that gets around a lot of common problems. So a lot of times when I'm doing this, I'm trying to debug something that actually gives me access to my boot device. So I need it in the flash memory system for Petitboot itself. So I have been building this stuff right into the PNOR, little scripts and tools, and like usually the temp directory that just lets you get around some debug problem or bring up problem, and you can just include it right in the PNOR. Now, you're going to be limited by the space of that PNOR. You can't just go on and on forever, but for a lot of simple things, that works perfectly well. And like I said, that gets you around the issue where you can't even get to your boot device, you can't even get to your network device, so there's no way to add that on externally. So, thank you. So then once you get to the Petitboot 1.7 version, they've started including this interface called the Petitboot plugin, and that's going to give us a lot more capabilities. This lets you do a prepackaged set of tools, a prepackaged set of scripts and facilities that are in this plugin that then you could just mount an NFS volume, and you can include that in your Petitboot system. Or you can put it on a USB stick and include it in it that way. And this, again, is all pre-boot environment. Now, when I get to the next slide here, I mean, a lot of this stuff is important in the refinement of your bring-up. You might have, your system that you get first running, but then you have some intermittent issue with a certain adapter, maybe some clock chip or something. And these kinds of things are often, in my experience, so much easier to resolve in this Petitboot world where you don't have to worry about if something goes awry, crashing your installed OS that took you, 20 minutes or whatever to install. If you crash Petitboot, you can reset the system and be back in the console in a matter of seconds. And when you're first making mistakes and learn about things, like learning, diagnosing the nature of the fail, that's extremely liberating. It lets you get Another example there is when you are exercising a key component, maybe something that has already exposed a weakness in the hardware, an adapter that doesn't train perfectly every single time. So you can sit there and just repetitively cycle that piece of hardware in Petitboot much quicker and easier than sometimes you could do in a booted operating system that has all this other overhead going on. So these are some typical bring-up things that we've used Petitboot to resolve. Sometimes you're trying to figure out what a fan controller is doing, so you can access that through an I2C bus in Petitboot. We've also got some tools that I've created, and a bunch of groups inside IBM have used this. A bunch of the OpenPOWER OEMs have also used this for bring-up, that will let you initialize a little embedded EEPROM on a PCIe switch. And, you know, we can just build that system with the EEPROM blank, install this script, and then it will, on the first time the system IPLs, it'll initialize that EEPROM for you, and then all your downstream devices are ready to go. You can verify and diagnose your link training issues. Like I said, if you've got a system where a specific PCI link is not training reliably, you can just sit there and iteratively cycle on resetting that, checking the link, resetting it, checking the link. If it trains reliably, you know, at by 2, you can strap that port off to by 2 or whatever. There's just all kinds of capabilities that are much simpler from the Petitboot environment than, you know, trying to do this in a live OS where you could actually mess up a device driver or something. There's also like GPIOs in some systems, I2C muxes. Sometimes you're trying to make sure a pathway works so you can hit a power controller. We've done all kinds of things like this to help bring early systems to life. And then, you know, there's the stuff that so much of the OpenPOWER environment, our host boot and our Petitboot, a lot of that stuff is based on the content in the machine-readable workbook, the XML that defines the system. So, you know, and a lot of times we're trying to resolve issues there. Some DIM can't be recognized or something, and that's usually, you know, traceable to some issue in the machine-readable workbook. So we want to make sure you can get access to all that. As I've been doing this, I have, you know, figured out the things that have worked best for me is get my tools to actually be configured and set up by information in either the machine-readable workbook or sometimes in a separate configuration file. That way, the stuff I've done for like the PCI switches, you modify the configuration file to define the switch in your system, and then all the tools just get created automatically. And it gets built into your ROM. It's all ready to go. So as I've moved this to different OpenPOWER systems over the last couple of years, it's made that process even more seamless and easier to do every single time. And, of course, we've got our OpenPOWER reference designs. So I include, you know, configuration files for the Firestone, the Palmetto, the Habanero, the reference designs that everybody knows about that are documented on the OpenPOWER site. You know, one of the things I've also learned is if you have a tool or something that needs a certain level of Petitboot, you want to make sure you identify that and, you know, include that in your build file. I've had to work around some issues around that stuff. And then also, you know, put that out on GitHub so that other people can use this capability. I am going through that process right now at IBM to get a bunch of these PCIe switch tools through the internal review process so we can get that stuff out on GitHub and make it available for all the OpenPOWER clients. But if you're an OpenPOWER OEM and you need help with something like this, please talk to me offline. I'll be near this OpenPOWER Pavilion practically all week. And I love talking about this stuff, and I love helping our clients solve problems. So please don't hesitate to ping me, and I would love to help you out. Learn what I've figured out from this last year, that Petitboot is just a unique environment for giving you this flexibility to bring up your system faster, cleaner, easier, and in a way that so often where we used to use hardware aids, you just often don't have to mess with that. You know, the little USB to I2C type adapters that used to spend a lot of time with. It's just not necessary so much anymore. That's about all I had today. If you have any other questions or comments, please be look for me over here in the pavilion. I'll be happy to talk to you. Thanks.